fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. So I hope you guys are getting excited because we are officially in June, and that means WWDC is in a couple days. When this podcast goes live on Saturday, we will be 2 days away from WWDC, and you know that next week we will have coverage about the event right here on the Dark Assassins podcast. So make sure that you tune in to catch that coverage. But to start off this week's episode, let's get into this week's trivia question. So this week's trivia question is, who is considered to be the father of the World Wide Web? So that thing that you use your internet browser to search and use, the World Wide Web, who is considered to be the founder? That is your trivia question for the week. Now, I know I've talked about it, I guess, a little bit when I talked about my Xserve RAID and getting that fully working, whenever that was, like a couple weeks ago. Recently, well, I guess part of that, I kind of got the idea that I should do something about that aside from just making the flashy, blinky Christmas lights. So Xserve fans of Xserve content and my blog reader enthusiasts will be happy to hear that I have something cooking for you guys. So you're definitely going to want to stay tuned for that. Now, the funny thing about the blog is it's something that I have, but I basically I don't say never update, because in all honesty, I update it significantly more than any of my social media accounts. I update those I think at this point it's lucky if I update it once a year. And I think some of them I haven't touched in coming up on 2 years at this point. So been a minute on those. But the blog, on the other hand, it's been updated a few times. It's like at worst, it's like maybe a yearly thing, and then at best, it's like maybe quarterly. It's kind of one of those things where if I get an idea for something, I might do something about it. But I figured Xserve RAID, that's pretty cool. So when's it gonna be out? I don't know. I mean, I'd prefer it to be out kind of soon, but you know how these things go. Might be a little bit, let's just say, I guess you'll hear about it when it happens. But yeah, I got that cooking. I think I have a decent amount of it done at this point. I got like some of the background and like intro stuff, but at some point here I'll have to fire that beast up again, and get some screenshots and whatnot to add to it. You know how it works and how to configure it and all that stuff. So there is still some more work to do, but it is at least has a good head start to it. But with that out of the way, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, I figured since we talked a lot in the past about ways to protect yourself to prevent against cyber attacks, but just as important to prevent against cyber attacks is to have a plan if and or when a cyber attack occurs, or any kind of hack or ransomware, any of that happens. You want to make sure you have a plan in place so if it happens, you know what to do. Because the last thing you want to have happen is ransomware come in and wreck your system, and you're freaking out. You have no idea what to do, and because you don't have a plan, it jumps to another device on your network, and then it jumps to another one, and now it's on your NAS, and now all your backups are gone. So you want to make sure that you have some kind of plan in place in the event that some kind of cyber attack happens. So there's a few steps that any good incident response plan will have. And the first thing is to make sure you lock everything down. And when we say lock everything down, if you know it's only on one machine, you basically want to isolate that thing as quick as possible. Make sure it's not connected to the network. Maybe even power it off. You just want to make sure you get it isolated to limit the attack surface and the attack vector that the attacker or the malware or whatever can spread to, because the quicker you can contain it, the easier it'll be to clean things up. Because if you only have to deal with recovering one machine, that's a lot easier than having to recover every machine in your house or every machine in your network or everything in your home lab or whatever the case may be. The less machines you have to recover, the better. So ideally, you want to lock everything down as quickly as possible. So that is the first thing you want to do. And then the second thing you want to do is you want to make sure you have some kind of priority in place of recovery processes. So if, say, your NAS went down and your personal computer went down, and then maybe your VM for Jellyfin went down, you're probably going to have a priority of which ones you want back. Whether that's your NAS you want back because you want other devices to connect back to it, or you need your personal computer back because you want to do some personal projects, or you have some schoolwork due, or you have your taxes that need to be done, or some other thing that you need your personal computer for. That would probably be pretty high on the priority list. But unfortunately, as fun as Jellyfin is to stream your content from, it's probably not as high on the priority list as some of the other things that could be there. So that's something you want to know, is what order do you prioritize stuff when it comes to recovering stuff. So obviously the things that are more critical, you're going to want to make sure those get recovered first. And then once you kind of recover from the attack, you want to analyze what happened. You want to figure out, how did this hack attack how did this attack happen in the first place, and what can be done in the future to prevent it? So was it you were going around on them sketchy websites and accidentally clicked the big green download button and ran the executable? Or did you fall for a phishing attack? Or did you have an open port on your router to some application that shouldn't have been exposed to the internet? Was it a flaw in your web browser? There's a lot of potential ways that an attack could occur and get you. So you want to identify what the attack vector was that got you, and by understanding that, you can understand how to improve your security. So maybe if it was that application that had a port open on the firewall, okay, I'm going to close that port off and make sure that application isn't, accessible to the internet. Or maybe you had an application that was fine being accessible to the internet, but it was kind of lagging behind on the security updates, and it got, exploited through one of those. So now all right, I really need to make sure I keep updated on all my security patches and whatnot. Or maybe you clicked on a phishing attack, and okay, well, next time I need to make sure that I closer inspect the URLs that I'm clicking on and sites that I'm navigating to. So just kind of analyzing what went wrong, and that way you can better understand how to prevent something like this from happening in the future. So hopefully that was helpful. I know we talk a lot about how to prevent cyber attacks, but if an attack happens to you, it's just as important to know how to recover from one as well. So that is your cybersecurity tip for the week. Now, this next thing, I'm not really quite sure of who needs to hear this, but I know I definitely needed to hear it this week, so that's why I'm bringing it up. And this advice that I'm going to give is for the developers out there, myself included, because I definitely needed it this week, and that is suck it up and code. Now, that is a pretty bold and inconsiderate statement, so allow me to explain myself a little bit. So when I say suck it up and code, I think it's safe to say that no matter where you are in your software development journey, whether you are new to software development, you're taking classes in high school or undergrad or learning online by yourself, whether you're a junior developer at some company, whether you're a senior developer, it doesn't matter. You're going to run into a situation where you're going to be tasked with either working in a new programming language, working with a new framework, working with a new code base. I mean, you're going to run into some kind of scenario where, quite honestly, you have absolutely no idea what you're doing. And it doesn't matter how much programming experience you have. If you are tasked with writing in a language you've never used before or coding for a code base you've never touched before, it doesn't matter who you are. It's going to take time to come up to speed and actually figure out what the heck you're doing. Now, the reason why I say suck it up and code is because whining and complaining about the fact that you have no idea what you're doing and throwing your hands up ain't going to write the code any faster. I mean, the code's not going to write itself, right? Unless I guess you're using ChatGPT, in which that is code because it's AI and it's writing code itself. But if you've ever used ChatGPT to write code for you, let's just say you have a couple possibilities for your outcome. Either one, it works, but the quality is sometimes suspect. So that's like a best case scenario. A more average case scenario is like the concept's kind of there, but it doesn't quite do what you want. Other times it won't even compile at all. Other times it's not even what you asked. And the other thing you have to keep in mind too is any kind of query or any kind of code snippet you give it, it's going into the big AI database heap in the supercomputer somewhere in the cloud, AWS, Google, Azure, wherever. It's going somewhere. And that's just going to be used to train future models. So if you're using I guess I'll just say there's a reason why the larger tech companies such as like Apple, Google, AWS, and the like don't let their software developers use AI tools like ChatGPT to help them write their code, because you're just asking for your code base or parts of the code base to be leaked out into the ether by asking these AI tools to help you with your code. So no, the code is not going to write itself, and it shouldn't write itself because you're just asking for problems. So with that out of the way, yeah, the code's not going to write itself. The only way the code is going to be written is if you, the software developer tasked with writing it, actually writes the code. So just sitting at your desk or at your computer or coffee shop or wherever you're coding and just whining and complaining about it is not going to write that code. Now, on the one hand, I guess you could say that you just kind of need to take a minute to have an existential crisis and have a mental breakdown, and then you can get into the code and actually knock some stuff out. In that case, if that's what it's going to take, then I guess by all means. But whining and complaining is not going to do it. Because one thing that I've noticed in my personal experience, both working on personal projects, school projects, and professionally, is when I throw my hands up, it's just not productive at all. I can't tell you how many times I've experienced, have dealt with people that will look at the code, work at it for like a couple minutes, run into an error, try to fix it, still doesn't work, and then they just basically just give up. And that's not the attitude that you want to have, because if you give up at the slightest, little bit of inconvenience in code not working, I have some. Let's just say your future career endeavors might not be as bright as you think they'll be. I mean, that might sound harsh, but that's just how it is. Like, you're going to be expected to be able to deal with adversities and learn code bases and that you don't know, and power through problems that you have. That's just part of the thing, right? So, and a large part of being a software developer is the problem solving aspect. Like, there will be times where you'll be in a quote unquote coding session and you might only write like a couple lines of code, if that, because you're trying to solve a problem and figure out what you need to do, or you're hunting bugs or something like that. Sometimes you'll be in a coding session for hours, and if you're going purely based on lines of code written, it would look like you did absolutely nothing because you were trying to solve problems. So if you don't have the ability to solve problems, you're going to find it very difficult to be a successful software developer. So, which is, again, where the idea of suck it up and code comes into play, because personally for me, I've noticed that, like, when I run into a problem that I don't know how to solve, basically what I'll do is just head down, hands on the keyboard, and just go ham, just right into the code, just diving into it, and just hacking away at it, beating my head against the wall, trying to get it to work. And eventually it somehow, some way, it manages to work itself out and I get it to work. Now, I guess a couple tips that I have when it comes to just sucking it up in code, because one thing I guess that I've kind of talked about today, and I think I might have mentioned in the past, there's a lot more to coding and software development than strictly just click-clacking away on the keyboard and writing lines of code, writing if statements, writing for loops, and all that good stuff. There's a lot of problem solving, a lot of bug fixing, a lot of understanding what the code does, a lot of researching. There's a lot more work that goes into quote-unquote coding than just typing away on a keyboard. So when I run into instances like this where I have no idea what the heck I'm doing, and I don't know what the code base does, or I don't know what the framework does, or how to use it, or I've never used the programming language before and I'm trying to figure out how to use it, my go-to solution for that is basically hack the code up and just mangle it all to heck and figure out what it does. Now, we've talked in the past about how crucial a debugger is, and a debugger probably couldn't be much more useful I mean, it is very useful for solving bugs and finding bugs and that kind of a thing. But it's also super useful for stepping through line by line in the code and figuring out what each line does, checking, what variables are at certain instances, stepping into different functions and seeing how the functions work. So basically, when I'm tasked with something like that, I will just hack the code up, either put a bunch of print statements in there to figure out where things are, what things are doing, use the debugger, like I mentioned, to kind of do the same principle, and really just like dive head in and just envelop myself in the code, not really even actually writing any code, but just like going in and understanding what the code's doing, jumping to definitions of functions, looking at, different function calls, the documentation, if any exists, reading the comments in the code, and just really just trying to understand what the heck it's doing. Because the sooner you can understand what the code's doing and what the code base is doing, or how the programming language is implementing certain things, the sooner you'll be able to actually write code for that framework, that code base, that programming language. And the sooner you can do that, the sooner you'll encounter bugs, and the sooner you encounter bugs, the more you know the code base, the better you'll be able to understand what might be causing those bugs and help track them down. So really, at the end of the day, if you don't know what the heck you're doing, you really only have one option, and that is just to batten down the hatches, lock yourself in a room or at your desk, or just it's just you and the code. Just get into it, because it's not gonna, at least as of right now, there's no way for you to download the entire knowledge base of the code base and how it works and all the ins and outs, so you can instantly be up to speed on how it works. That's unfortunately not how things work right now. So the only way that you can really understand what you're doing is just to basically put in the time and the effort to understand it. Now, if you have people that you can talk to and ask questions to, that's also a pretty valuable resource. But sometimes I've even found that I get better results just by banging my head against the wall and just hammering it out until I get it to work. Since I've had instances in the past where I've asked questions about, certain problems I was having, and pretty much didn't get anywhere, and then just beat my head against the wall with the code for a while and eventually figured it out. One instance I remember pretty vividly was one time back in college. For whatever reason, my code wasn't working, and I was emailing with my professor, and even went to their office hours and sat down with them for probably at least half hour, 45 minutes, maybe a little more, and they couldn't figure it out, and the assignment was due like in a couple days, and you know what I did? I sucked it up, beat my head against the wall, pounded away at the code, and you know what happened? My professor did not answer me back, didn't help me. I figured it out on my own and got it done, which is basically how I've kind of learned to operate. Is if I don't know how something works, just gotta go into don't talk to me mode and just dive head on into the code and just really get into it, figure out what it's doing, and just hack away at it until it works. So I'm not sure if anyone out there needed to hear this message, or if this was just a message for myself. But if you're ever just stuck and the code's not working and you don't understand it, really the only solution you have is just to do it. Nike, just do it. Yeah, this was actually this whole thing was just a long ploy for the Nike sponsorship that is totally happening right now, and I'm not just making this up as a mere coincidence. Yeah, it's just a mere coincidence. But yeah, maybe it doesn't work for you to just suck it up in code, maybe. But I mean, in some instances, you don't really have a choice. If you're kind of the only developer around, like if you're working on a personal project, for example, working with a new library or a new framework for a personal project, you don't exactly have any senior developers on your team to turn to if it's literally just you. So in those cases, you're pretty much your only option is to suck it up in code and just figure it out yourself. And honestly, by figuring it out yourself, I think there's a real value to that you learn a lot, not only about the code base, but you also learn a lot about yourself and how you figure out for yourself the best ways that you can learn, and the fastest ways that you can figure things out is just by doing it yourself. I think there's a reason why I don't remember exactly what the saying is, but basically, if you kind of the idea of if you worked hard for something, the reward of getting that something is a lot nicer, and you treasure it a lot more than if someone just gave it to you, right? I think it's the same thing, with coding and software development too. Like if someone just shows you and tells you how to do something, yeah, it's nice and easy and saves you some time, but if you actually have to go through and put in the work to bang your head against the wall, fail a bunch, and figure out how everything works, then once you actually get it to work, the payoff is, I think in the long run, is definitely a lot better, since throughout that whole process became a better developer because of all the work that you had to put in to figure out what the issue was or how the code base worked, and it just overall makes you a lot better of a developer by just sucking it up and coding, I guess you could say. So yeah, that was, I guess, my advice for anyone that needed to hear it. So I guess with that, I guess we can get into what nerdy stuff have I been up to this week. So this week, I've kind of mentioned, working on that special blog post, I guess, with the Xserve raid. But the other thing I did was I've been talking a decent amount over the past couple weeks about kind of redoing some of the Pokemon code for the game I'm working on and trying to optimize everything. And I think I pretty much got it back to the state of working and functionality that it was in before I started this whole rewrite process. So I got so basically everything that the I guess more bloated versions of how I was representing Pokemon, those classes, I pretty much fully swapped and switched over to the more streamlined and optimized versions, and have everything working as it was before I started that transition. So I think we're pretty much in a pretty good state there. So that was pretty good to see. And speaking of kind of redoing and refactoring stuff, that kind of leads me into another topic that I wanted to talk about. I guess another message to the developers out there. When it comes to refactoring your code, the key is don't cheap out on it when it comes to refactoring. Basically, don't let a temporary fix or a hack become your long-term solution, because I guess we can do is we can take a step back here and talk about, for those who might not be software developers, What the heck is refactoring and why do you do it? So when you're writing software, the chances of you writing something perfectly in the most optimal way for the given problem on the first try is generally not super high. In which case you get through working other parts of the code and then you realize, oh, my original solution isn't going to work here, or, oh, I figured out a better way that I can implement this, so I found a new algorithm that works better, or I want to use this data structure to improve the usability, or whatever the case may be. You come up with a better idea of how to implement something you already did, so you essentially go back and rewrite the code. And that's essentially what refactoring is. Now, there's different stages. There's like complete rewrites where you basically redo everything from the ground up. There's other rewrites where you might just redo like a couple functions or something. There's different levels when it comes to refactoring. But one thing that I myself am guilty of, and I'm sure a lot of other developers out there are also guilty of, which is not a good thing, is you'll be in the process of refactoring your code and you break a lot of stuff, which, I mean, obviously that comes with the territory of rewriting parts of your code. You wrote it to work one way, so if you change how it works, it's obviously not going to work anymore. So by rewriting maybe just one function, that'll kind of lead you down this rabbit hole of having to rewrite other parts of your code elsewhere, which in some cases, if you're doing a lot of refactoring, you can find yourself either writing in hacks or quote unquote temporary fixes, emphasis on the temporary, because we all know those temporary fixes end up staying in the code base long term and become your permanent solution. But the goal of the temporary fix is to be kind of a stopgap while you work on other parts of the code, to be kind of a bridge to allow your code to still work while you rewrite portions of it. And the problem is, once your code is working again with your refactor done, it's very easy to either forget that you even put the temporary fixes in the first place, or you're just so happy that the code finally works after hours or days of it not working while you refactor it, that you're just so happy it works, you're like, all right, I'm done, I can move on, with those temporary fixes, if you can call them that, still in the code. And generally, these are not very clean solutions, right? Like, you'll have magic numbers in there, and for those who aren't developers, a magic number is any kind of number that isn't a variable. So if, for example, if you're writing a networking program, rather than having a variable called port, and whenever you need to reference the port number, saying port, instead, you would use a magic number, or say if your port's like 8080, you would have 8080 mixed throughout your code. And the reason why this is not a good idea is because if for whatever reason you need to change that port number, you now have to go back through all of your code, all your classes, all your functions everywhere, and figure out where you put that 8080 magic number and change it. Whereas if you used a variable, you just have to change where the variable gets initialized and you're good to go. So yeah, sometimes temporary fixes or hacked approaches will, if they don't do something specifically like that with magic numbers, they'll do something to the same effect, where it's generally not the best coding practice, but at the end of the day, yes, it technically works and gets the job done, but it's not exactly the cleanest or most elegant solution. And the reason why you, in my opinion anyway, you don't want to have these is because the whole point of the refactoring process was to improve your code, not make parts of it worse. Because if you make parts of it worse, then you're just going to end up going back and redoing those parts later, potentially, and then that could make you potentially have other, quote, temporary fixes, and then it just kind of spirals out of control, and next thing you know, your entire code base is a bunch of temporary fixes, and your code base is just a big old plate of spaghetti. And if you've ever tried to work with a spaghetti code base, you know that it is, one, not fun, two, it's basically impossible to do any kind of productive work because everything's all over the place. So trying to figure it out and kind of untangle the spaghetti is a process in and of itself. So the more temporary hacked fixes you have, the more likely your code's going to turn into a bunch of spaghetti. So you may want to make sure that you don't keep those temporary fixes in there. And the ideal solution would be I say write the code right the first time, but when I say that, I obviously don't mean that like you can never go back and refactor it, because that's kind of an inevitability, but rather just try not to put a hacked solution in there in the first place. Like in the case for the refactoring that I was doing with my code, rather than trying to do some kind of hacked temporary solution, basically what I did was I just essentially wrote a complete new suite of test cases and different tests to verify the new code that I wrote worked as intended before I started swapping over everything in the main code base to the new version. So that way I basically prevented myself from having any of these temporary or hacked fixes in there, because trust me, I definitely easily could have had some hacked fixes in there, and I was kind of tempted at some points, but I was like, nope, I'm going to be good this time, and I'm not going to do that. Because I've done it before where I've redone some code and realized parts of it weren't working, so I added a, quote, temporary fix that ended up being part of the permanent solution, which obviously is not that great. So yeah, if you're ever planning on refactoring your code or a code base for work or for school or whatever the case may be, try to do it right the first time, in the sense that you don't put any temporary fixes in there. If you're going to need to do some kind of temporary fixes, I think it's probably better to test everything like while you're doing the refactor to make sure it works kind of siloed off, I guess, if you will. And then once everything's working as it should and the refactor's done, then you can move that and migrate it in to the rest of the code base, so you don't have to worry about even putting any temporary fixes in. And with that, there was one other thing that kind of caught my attention this week that I thought was quite interesting to talk about, and that is this whole drama going on right now with the Dolphin emulator and Nintendo. So if you haven't heard about this story, basically Nintendo is blocking the release of the Dolphin emulator from Steam. So Steam, if you're not aware, is a way that you can like download games and whatnot for your computer. And the Dolphin emulator is an emulator that allows you to play Wii and GameCube games without actually needing a Wii or GameCube, the physical hardware, to play them on. So the reason why Nintendo, I guess one of the main reasons why they're citing the reason for this takedown is basically the Dolphin emulator, it makes use of a Wii common key in the emulation, which basically actively bypasses the piracy protection measures. So basically allows you, I guess, to have pirated games or whatever, or ROMs or whatnot. So Nintendo said with Dolphin using, in regards to Dolphin, I guess, using these keys, cryptographic keys without Nintendo's authorization, and decrypting the ROMs at or immediately before runtime. Thus, the use of the Dolphin emulator is unlawful and circumvents the technological measures that effectively control access to a work protected under the Copyright Act. So, basically, Nintendo's stance on this is the Dolphin emulator is circumventing some cryptographic checks they have in there to make sure the ROMs are legit, which, like, I guess I can say I understand where they're coming from in that sense, but I guess on the other hand, if it's literally that easy to bypass your, I guess, security checks to make sure that the games you're playing are quote unquote legitimate, I mean, can you really blame them for doing that? Now, I have heard some people say that, maybe rather than actually putting these keys in the code base of Dolphin itself, you would have to like supply your own or something like that. But I guess this comes down the whole argument that's kind of being made, which in this IGN article, which I'll also have linked down in the show notes, where Nintendo is saying using illegal emulators or illegal copies of games harms development and ultimately stifles innovation. Nintendo respects the intellectual property and rights of other companies and in turn expects others to do the same, which, first off, I think we have to say that the use of like emulators in general is kind of a gray area, but the use of an emulator on the premise of using an emulator is not illegal, which if you're ever trying to do any kind of testing for some machine type, an embedded system, a video game console, if you don't actually have the hardware itself to test your code on, you need to use an emulator to emulate what it's like to run the code. So, for example, we've talked in the past about on Macs and whatnot, they have Apple provides an Xcode emulators for iOS and iPads, and I believe the Apple Watch 2 and Apple TV. And we also talked about, one thing I was curious about is how they would implement some kind of emulator or simulator for the virtual reality, mixed reality, or whatever they're calling it, the headset, which is supposedly rumored to be coming out in a couple days, or at least be announced. And that was one thing I was interested in. Now, you can also make the argument there that those emulators are legitimate because they're made by Apple for Apple devices. So, sure, that is a legitimate argument. But on the premise, emulation is not illegal. Now, the main kind of gray area you get into is just like last week's episode where we talked about piracy, is how do you acquire the games or the ROMs for the games that you are then playing in the emulator. And that's, I think, where the main gray area comes into play. But just a quick news flash for Nintendo here. You don't sell any Wii games or GameCube games. Like, it's literally not possible, at least that I know of at the moment, for you to buy a Nintendo Wii or GameCube game from Nintendo. So if there's no means for you to purchase a game from the creator of the game, you could make the argument there that downloading it illegally is kind of your only option if you want to play it. Now, you could also make the argument that you could buy a used console if you don't already have one, and then buy a used game on eBay. But at that point, Nintendo's not getting the money anyway, right? If you buy a used game off eBay, Nintendo's not getting any of that money. If you download a copy from the internet illegally, Nintendo's not getting any of that money. And it's not like Nintendo can sell you the game anyway, so they're not going to get any money regardless of how you acquire said game. So some would argue that ethically speaking, if the company so in this case, Nintendo, if you were to illegally download a Nintendo game that Nintendo does not sell, and there's no way for you to buy the game from Nintendo, ethically, you're not doing anything wrong, because it's not like you're stealing from them, because they're literally not providing you any means to get the game. So an example of this, well, not specifically Wii or GameCube related, I guess, is say you wanted to play Pokemon Emerald or Pokemon Fire Red or Pokemon Sapphire, any of the Gen 3 Pokemon games. Unlike some of the other older Gens 1 and 2 where they had them available for digital download, which I guess technically, since the eShop on the 3DS shut down, I don't think they're available to buy anymore. So that, I guess you could maybe even rope those in too. But I know for sure, at least at this recording, that the Gen 3 Pokemon games, it's literally impossible to download a digital copy on any of the newer consoles from Nintendo, and obviously Nintendo won't sell you a physical cartridge of the game. So literally, if you want to play one of those games, your only option is to go on eBay or some other third-party marketplace or used marketplace and buy a game that way. Or you could buy a replica cartridge from somewhere over in China for dirt cheap, but again, that's not a legitimate copy either. Or you could illegally download the ROM and play it on an emulator. And one of the benefits to playing older games on emulators is you get basically all the luxuries that modern hardware can provide. So you can get better resolutions, better frame rates. There's a lot of benefits, like legitimate benefits, that people have, that you can have playing on emulators, and why people do it. But the other thing that it goes back to also, as we talked about last week with the efficacy and the ethics of pirating like movies and TV shows, is what if you already own the game? Like, what if, say, so in this case, Nintendo, say you already owned Madden NFL 2006 or whatever. Say you already owned that GameCube game, but you wanted to play it in higher resolution, with better frame rates, on a bigger screen on your TV. So you want to put it in the Dolphin emulator, and you already own the game, but you have no means to get the ROM or the game data off of the disc that you already own. In that case, you could, if you download the game illegally, technically you're pirating it and committing a crime. But as we already mentioned, it's not like Nintendo sells that to you, so it's not like you can actually buy the game new. So it's not like you're stealing any revenue that they would have otherwise made. And also, you literally already bought the game. You already own the game. So there are there's definitely valid arguments for both sides of the emulator debate, but I think a lot of it goes back to the fact that if you already own like, say you already own the console, like, for example, I have both a GameCube and a Wii. If I wanted to, play, games on an emulator, I mean, technically, if that emulator, according to Nintendo, is using like illegally acquired keys or something to bypass security checks or whatnot, I mean, I already own the hardware. So if I wanted to play the game on the actual hardware, I could. And similarly, it's the same thing with the games too. If I already own the game, and I wanted to play it in an emulator for some reason rather than real hardware, I mean, I already own the game. I already gave you the money for it. But then on the other side, Nintendo makes the argument that you're stealing from developers and whatnot. But I think while that is definitely 100% valid in every sense of the argument, I think the main hole in their argument, again, I'm not a lawyer for any of this legal stuff going on. I think the biggest hole in their argument is the fact that they literally provide zero way for you to actually buy the game from them. So, like, even if you, like, as I mentioned, right, even if you acquire the hardware and the game legitimately through some third party or from some reseller or something, it's not like Nintendo or any other game company or whatever is making money off of that transaction. So it's not like you're stealing from them anyway. So I think that's potentially where they have a hole, at least in kind of the ethical realm. In the legal realm, I have no legal opinion on that, since, as I mentioned, I'm not a lawyer. But that's kind of, I figured it was something in the technology realm. We've talked about video games in the past, and it kind of ties in with last week's episode also. So I am kind of interested to see where this goes. But this isn't the first time that Nintendo has kind of thrown a fit over emulators and emulating video games, which, I mean, the thing is, like, if you want younger people to experience these older games, pretty much the only way to do that is through emulation, and that'll expose them to, older games and maybe kind of get the experience. Well, I guess not the experience, it's not the real hardware. But in some cases, like, it's cost. There's a cost prohibitive aspect to playing retro games. I mean, if you look at some of the prices for like used consoles and used games, I mean, it's like way more expensive than like new games that are like out now that you can actually buy. So it can be pretty cost prohibitive for someone that wants to play these older games but doesn't have either the hardware to play them or the actual physical copies of the games, which is where emulation could come into play and allow them to have that experience. But again, I mean, it's not like Nintendo is selling GameCubes or selling Wiis anymore, or selling any of the games for those consoles. So it's not like downloading an emulator that someone made, or downloading a ROM that someone uploaded of a game that you want to play that is no longer sold anywhere. It's not like you're stealing revenue that the company would have otherwise made if you didn't, download it, right? Now, obviously, that's completely different if you are, say, downloading I don't even know if there's like PS5 emulators out there, but let's say hypothetically you had a PS5 emulator for your computer with your RTX 4090 and your Intel 13900K, or your beefed out Max machine, right? And you download a PlayStation emulator and you download a bunch of ROMs from the latest PS5 games, then you can definitely you definitely don't have the ethical argument on your side in that case. That is for sure, because obviously those games and the console is still being sold by Sony and by the developers and whatnot. So in that case, you are definitely stealing from people, because you can obviously still buy that stuff. But yeah, when it comes to older stuff, there's definitely a lot more gray area, I guess you could say, and there's definitely arguments to be made on both sides. And I guess since I don't have a good way to wrap this segment up, I'm just going to leave it up to you, the listener, the fellow assassin listening to this, to decide what you think about this whole situation with Nintendo and the Dolphin emulator and emulating older games such as Wii and GameCube games. But before we leave for this week, let's get back to our trivia question, which is, who is considered to be the father of the World Wide Web? And if you said Tim Berners-Lee, you are correct. And the reason why he's considered to be the founder of the World Wide Web is because he did a lot of work in pioneering and developing the foundations for the web. So this is things like the HTTP or the hypertext transfer protocol that's used on the web, and also the HTML, or the hypertext markup language, which is kind of the main way that if you ever write a website yourself, you're going to be using a lot of HTML for that, which is kind of like now I guess you could argue there's more JavaScript in there, but when the websites that I work and maintain, and like I mentioned, the blog post I'm writing, that is all, not 100% HTML, but all the code that I write for it is basically 100% HTML. And he also did work on the first web browser too. So that is the trivia question. Tim Berners-Lee, father of the World Wide Web. And that's going to do it for this episode. So if you enjoyed, I ask that you leave a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already, since you're not going to want to miss next week when we cover WWDC. Also, be sure to share this episode with a friend or family member. Maybe you have a developer you know that needs to hear any of the messages, either of the messages that we talked about, whether it's suck it up in code or how to refactor the right way. And if you have any questions about this episode, or you have any topics or ideas for future episodes, feel free to shoot me an email at contact@darkassassinsinc.com. There is a link, as always, in the show notes down below for that. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.